Hello, we're going to talk a little bit about the properties of exponents today. We're going to go over several of these. First, we're going to talk about the multiplying powers with the same base. So if you're multiplying powers with the same base, the rule is pretty simple. You keep the base and you add the exponents. Here's an example with numbers. We have 3 to the 5th power times 3 to the 8th power. We just took and we added that 5 plus the 8, which gave us 3 to the 13th power. Here we have with algebra, meaning with variables. So again, we have the same base here, different exponents. So you would just add those exponents together. So here are two examples, if you want to pause for a second and do those. So you're going to add the exponents as a reminder. They have the same base. So that gives us 6 to the 6, and then 6 plus 3. Or your exponents there. So you would add those, which would give you 6 to the 9th power. Sometimes they have you solve that out all the way, but a lot of times they leaving it just as 6 to the 9th power is fine. All right, so same thing down here. We have the same base in the end. We have different exponents. Again, same rule. You're going to add those exponents. So we would take n and then 5 plus 7, which would give us n to the 12th power. All right, here's a couple more for you to do. Let's point out here, this 2 does currently not have an exponent, but we should know that there is an invisible exponent there. It is a 1. So make sure you remember that as you're solving these. Go ahead and pause and solve that now. All right. So, sorry, I just told you that. That would be 5 plus 1. So that would give you 2 to the 6th power. The next one, if you add, again, you have the same basis of 24, add your two exponents, 24, 4 plus 4, which would give you 24 to the 8th power. Notice that what occurs when you divide powers with the same base. So here's an example. If we had 5 to the 5th power over 5 to the 3rd. So if we actually wrote that out, what does 5 to the 5th power mean? Well, it means 5 times 5 times 5 times 5 times 5. And 5 to the 3rd power means 5 times 5 times. Okay, we know that. But what we can do is we can a lot of times cross cancel because we know that 5 divided by 5 is 1. So if we cross cancel, we cross out 1 here and 1 here because that equals 1. We cross out 1 here and 1 here because, again, that equals 1. Same here. We are left with 5 times 5, which means we are just left with 5 squared. So what did we do there? If we go back to this original problem, pause for a second and think, how could you solve this knowing what we just did here? How could you solve this? I mean, nobody wants to sit and write out your numbers like this every single time you have a problem with division and exponents. So let's logically think, what would we do to the exponents here? Hopefully you've said subtract. So if you have powers with the same base, you're going to, again, keep the base and you're going to subtract the exponent this time, which makes sense because that's what we did here. Once we had cross-canceled everything, we basically subtracted. So here's some examples for you. 6 to the 9th power over 6 to the 4th power. Again, they subtracted the 9 minus 4 and gave them 6 to the 5th power. You don't need to solve that any further out. You can leave it just like that. Here's an algebra example with variables. Same thing. Let's look at a couple examples. I'd encourage you to pause the video and try those now. Okay, so if you did this, you would subtract your exponents. So 7 to the 5th power over 7 to the 3rd power would be 7 to the 5th power minus 3, which would give you 7 squared. X to the 10th power over x to the 9th power. Again, you're going to subtract your exponents, which would give you, and remember, it would give you x to the 1st power. What do we know about x to the 1st power? It is the same thing as x. Okay, here's a couple more. Go ahead and solve this. All right, subtract again. 9 minus 2 would give you 9 to the 7th power. E to the 10th over e to the 5th would give you, subtract the exponents, it would give you e to the 5th power. All right, last one we're going to talk about. raising a power to a power. You'll notice the big difference here is that we have an exponent in the parentheses and we have an exponent out of the parentheses. For me, I remember this because of these multiplication symbols in the parentheses. That helps me remember when I see these two numbers beside each other like this. It helps me to remember I need to multiply the exponents. So you would simply keep the base and you would multiply the exponents. So 4 times 5 is 20. There's your algebra example, same thing. You would read this as 9 to the 4th to the 5th, which is crazy. What this technically means is 9 to the 4th power 5 times. Okay. All right. So I'll give you a moment to go ahead and try those out. So for this one, again, you are going to do what? You're going to multiply your exponents. So 4 to the 4th power times 2. Or of 2, I believe is what they said. So that would give us 5 to the 8th power. Again, multiply the exponents. 7 times 9 would give us 6 to the 63rd power. Can you imagine if someone made you solve that out by hand? That would not be very fun. All right, here's a couple more. Multiply the exponents. 3 times 4 gives us 3 to the 12th power. 8 times 2 gives us 4 to the 16th power. This one's a little different. What's different here? There's a negative sign. But guess what? The rule stays the same. What are we going to do? We're going to multiply the exponents. So we would just multiply 4 times negative 10. That gives us 13 to the negative 40th power. You can have a negative exponent. We'll get to that later, but that is okay for now if you end up with that. All right, here's one more little thing for you to do. What you'll notice is this has them all mixed together. So if you'll take a minute and solve those out. Pause the video. All right, here we go. N to the 7th power, 8 to the 9th power, subtracting here, 10 to the 4th, subtracting your division here, t squared. We have 3 to the 10th power, m to the 38th power, 9 to the negative 72nd power. And this one's always interesting because 10, I'm sorry, I shouldn't have clicked that so fast, but 4 times 0 is 0. Well, 10 to the 0 power, any number to the 0 power is going to give you 1. But we'll cover negative exponents and 0 powers in another video. All right, that's all for today. Thanks for watching.